Hello, and welcome to this DJ Instruments webinar. Now I would like to introduce today's presenter, Eric James. Eric is the General Manager at DJ Instruments. He is responsible for the market development and growth of DJ's key strategic initiatives, as well as the oversight of all global operations. Prior to becoming the General Manager at DJ Instruments, Eric held both product management and engineering management positions at Hardy Process Solutions, another company within the Roper Technologies portfolio, where he established himself as a proven leader across all facets of product development. Earlier in his career, Eric also held various sales and engineering roles at many different companies. Eric earned a bachelor's degree in chemical engineering from Lehigh University and an MBA from Northeastern University, where he specialized in marketing. Eric, welcome to today's event. And with that, I'm going to pass things along to you to get started. Eric, go right ahead.
Thank you for that nice introduction. Hi, everybody. I'm Eric. I'm the general manager here at DJ Instruments. So about a year ago, we gave a webinar that we went into detail about why you would use a pressure sensor and what function a pressure sensor has inside of a microfluidic pump system. This webinar kind of assumes that you know all that, you know why you need a pressure sensor, and you're trying to maybe learn a little bit more about what makes DJ different. If you haven't watched that first webinar, I really urge you to go visit our website, www.djinstruments.com, and watch that webinar. It's a good primer for this one. I'm hoping that in this webinar we can go into a little bit more detail, specifically about how proper hardware and sensor selection can help you as an instrument manufacturer achieve the value that you're trying to deliver to your end users. So to that effect, I'll start this presentation with just a broad overview of DJ Instruments, kind of who we are, where we came from, what we do. And then we'll talk about trends that I've noticed through some customer conversations in the instrumentation and diagnostics markets. Specifically, we're going to unpack two key value sentiments. The first is achieving repeatable, accurate measurement. We'll talk about preventing sample carryover, preventing bubble formation within samples, and maintaining sample integrity. And again, we'll take more of a hardware look at those areas. We'll also talk about improving the operating efficiency for the instrument end user through two areas, which is throughput and lab footprint, as well as reducing service needs and how we can do that through hardware selection. And then, I wouldn't be a good general manager if I didn't finish with a few product updates. So we'll talk about just some recent developments at DJ and things we're working on. So let's start with a little bit about DJ Instruments. We'll do just a brief overview. We were founded in Cambridge, Massachusetts in 1971. We've since moved to Billerica, Massachusetts to a little larger production facility. And back in 2007, DJ was acquired by Dynisco. Dynisco is a leading provider of pressure sensor and polymer test equipment that serves primarily the global plastics industry. Now, who DJ is? DJ is an original design manufacturer of strain gauge sensing technologies. We do pressure sensors, load sensors, torque sensors, and even center of gravity sensors for the missile and defense manufacturing industry. Who we serve is primarily original equipment manufacturers, and we offer specific value through our original designs to help them add value to their products. Our focus is on flow-through pressure sensors for a variety of life sciences industries, from liquid chromatography to clinical chemistry, microbiology, IVD, microfluidics, and the like. And we have manufacturing in both the U.S. and Malaysia. Our Malaysia facility is recently engaged to start producing these flow-through pressure transducers at higher volumes. So DJ's core competency within our sensor design is our design to fit program. We do really our best work when we're involved at the development stages of our customers' projects. So when they're coming up with new concepts and prototypes and pilots, we want to be involved in each step so that we can design our sensor to best match your system. That takes a variety of different forms, from electronics design to custom cabling and electrical interfaces to custom mechanical design and packaging. We have a wide variety of communication options: I2C, SPI, analog is probably still the most favored in the industry. We can do custom connectors and things like that to best fit the PC boards that are designed by the customer. And we can fit mechanical packaging that's really constrained. We go down to zero point 0.3 cubic inches, which is quite small. The end result is a sensor that's custom built for your system, and we do a very good job of protecting those designs once they're created. We're not going to take a design that we do for one customer and shift it over to another customer. We think that the designs that are done in cooperation with our customers are intellectual property, and we do our best to protect that. So that's a little bit about DJ. Let's transition the discussion a little bit towards the end markets that we try to sell into, which are analytical and diagnostic instrumentation. A little aside, this has been a bit of a wild year for me personally. I've gotten the opportunity to visit a lot of customers. The first 13 weeks of the year, I went to 10 different countries, from Europe to Asia to different manufacturers across the US. And as I start getting into the meat of this presentation, I want to highlight some of the high-level wants and needs that I've heard from some of the largest manufacturers throughout the world. This is by no means an exhaustive list. I'm consistently impressed by the depth of work that these companies are doing, and the things that they're thinking about really challenge me to do better work on my level. But I do think at a high level, what I'm going to share in this presentation in terms of value really captures the most important needs and the most consistently heard needs that I've heard. So let's dive into that. I think the first one is relatively obvious. We're talking about analytical instrumentation, diagnostic instrumentation. The first goal is to achieve repeatable, accurate measurement. And lately, the last couple of years, there's been this transition to try using smaller and smaller sample sizes, but getting the same accuracy. This has a lot to do with the invasiveness of patient procedures in hospitals and the like. So customers are working with smaller and smaller samples, and they need to see smaller and smaller things. Those things are a bit at odds, but that's where the market's going. So what you find is that errors in measurement become increasingly costly. A couple that we'll cover today, we'll talk about sample carryover, we'll talk about bubble formation, and just how to protect the integrity of your sample through good media inertness. As these samples that you're measuring are often blood related or human tissue related, having a media that is inside your system that matches what you need to prevent ruining that sample is increasingly important. So we'll talk a little bit about that. Another one that I hear a lot is that customers, or my customers who are the manufacturers of instruments, they're trying to differentiate based on sample speed and measurement sensitivity. Essentially, I see two breaks in the market. One is a diagnostic user. This is think like a lab hospital. I just want to do a ton of samples really fast. The separation mechanisms and the analysis mechanisms are all well understood. I just need speed and throughput. The other segment of this market is what I'm calling discovery, and now this is more like drug discovery or trying to create the right workflows to make analysis happen. These samples are much, much slower, but much more deep in terms of their complexity. So, these kinds of customers are looking for something a little different than the speed and the throughput. And what you're finding is that one segment is trying to bleed into the other. So you have these two distinct segments with two very different sets of needs, but you also see the manufacturers of these equipments trying to create instrumentation that are more flexible so that they can reach users in the other population, which makes a whole lot of sense, right? You're only going to develop a new instrument once every maybe 2 to 3 years. So you need that to reach the most amount of customers possible. So we'll talk a little bit about that and about how good hardware selection matters when it comes to speed of measurement and measurement sensitivity, and going back to measurement accuracy as well. Couple other trends. I notice a lot that instrument manufacturers are changing what their core competencies are. So it used to be that when it came to pressure sensing, a lot of instrumentation manufacturers would develop their own in-house solutions. They had the expertise to know how to make a sensor, and they would do that as part of their system design. What we're seeing now is that customers or manufacturers aren't looking to focus on that anymore. They want somebody else who understands how to make a sensor to make them a sensor that fits their system. They need to focus their engineering efforts on where it creates value for their end users. And what we're seeing is that's, the Internet of Things, that's user experience, other software features, ease of use. And there's a couple things driving that. Number one, laboratories and end users of these instrumentations are looking to improve operational productivity. So really finding new ways through software and user experience to deliver better technology, better data, fewer service interactions, fewer even user interactions on a hardware level. Customers are going down that path, and that's highly software related. The other trend that I think is well understood by manufacturers is that their end user has significantly changed. So it used to be that when you were working in analytical instrumentation, your end user was a PhD level person. And that still exists, probably more so in the discovery user segment. But on the diagnostic segment, your user has changed to more of a lab technician. And that brings with it a much different skill set. So the manufacturers have to really think about how they can make the job of that lab technician easier, because they don't have the broad understanding that a PhD would have about how to, tune a process or change the performance of the instrument. They just need it to perform reliably, easily, even familiarly. So I think that's causing, those trends are causing the instrument manufacturers to outsource more of their hardware design. They come up with the high level, and then they look to manufacturers like DJ Instruments to provide value in hardware where they used to create it themselves. And I think finally, the last thing I hear a lot is we need to get smaller. And I think this is common, kind of following cell phone logic, where, lab space comes at more of a premium. It's harder to fight for that benchtop space. You want to take up as little footprint within a hospital or an end user site as possible. Less materials consumption. Everything needs to get smaller. So creating smaller package sizes and less demanding equipment is important. So those are the four things that I'm thinking about as I go through my designs for pressure sensors. So, I'm thinking, okay, that's what my customers want to do. So how can my product help add value in those areas? So through the rest of this presentation, I'm going to unpack a few of these concepts, specifically as they relate to good hardware selection in the instrumentation that I'm selling to. And, we'll start that conversation with achieving repeatable, accurate measurement. So let's start with how hardware can help an equipment manufacturer achieve more repeatable, more accurate measurements. I think one of the concerns that I hear a lot of, both in my customers and manufacturers' marketing literature, as well as just in these direct face-to-face conversations, is this concept of sample carryover. And what sample carryover is essentially is when one sample affects the measurement of the next sample. So if you have any sort of trace bacteria or tissue or whatever other molecule you're studying from one sample that gets stuck in the process somewhere that affects the measurement of the next sample. Now, to prevent this, manufacturers are using a variety of solutions, and what I'm finding is that they're actually pushing a lot of it on to the end user level. Things like creating the right workflows and having strong wash processes. the use of blank injections to kind of clean out that process as they think about loading their next sample. A lot of this they're trying to automate, which is good, and that's sort of the responsibility that instrument manufacturers should take, but it is still pushed down to the user level. Even things like leak checking and regular preventative maintenance, all of these things help at a user level prevent system carryover. But what I'd like to talk about as a sensor supplier for instruments is what you can do on a system level to reduce your sample carryover or to eliminate it completely. I think the big thing that I've heard and that customers are asking of me is to reduce the dead volume inside an instrument. So they just don't want places where there's not consistent, easy flow through of material that both helps prevent sticky compounds from binding up in the system and getting trapped in the system, but also that's easier to clean as they implement these user level solutions. So let's talk a little bit about how we design our pressure sensors to try to eliminate this dead volume in a system. Let's start with some pressure sensor basics and just kind of understanding a little bit more about dead volume. Now, I gave a similar version of this presentation in the presentation I referenced from last year. I go into a little more depth in that one, but I'll try to hit the high notes here. So there's essentially, as I view it, three types of pressure sensors. The first is what I'm going to call a deadhead pressure sensor. This is a sensor that you would mount in a T in your process. And you can see that it leaves a cavity. And as you're thinking about sample carryover, that cavity is just a trap for material. It's really hard to clean out. If you really want to clean it effectively, you need to remove that sensor and actually go into that port and clean it out. It also just creates a lot of volume in general in your system, which again, we're talking about shrinking package sizes and shrinking the demand of the equipment inside of a system. That cavity is useless space that could really negatively affect your measurement. So that's one area. That's a dead volume sensor. Many sensor manufacturers recognize this and have created what's called a flush mount pressure sensor. This definitely does a better job of eliminating that dead volume, but what it creates, since it goes actually into your process and into the flow, is it creates a bend almost, or a corner. I like to call it a corner. And these are a little bit easier to clean, but they still have dead volume and places for material to get stuck, especially as you get into, really stickier compounds, blood, for example. It can get hung up in there, and you got to do a good job of washing it and cleaning it thoroughly. What DJ does is a little different. DJ designs a true flow-through sensor, and you can kind of see from this picture in the bottom right corner, there are no corners in this. The tubing, which is often a 16th of an inch, comes in. We make our sensor so that there's no corner. It butts up straight against the sensor, and you just have a clean flow-through pattern. So it's essentially just like tubing that can measure the pressure of your system. So not only does this eliminate the risk of carryover from the pressure sensor, but it also simplifies cleaning. You can clean it just as you would tubing. And the advantage of this is it has zero dead volume. So all of the volume that you're using is useful and easy to clean, and we think that's a pretty big value for our customers. Another area of measurement error is from bubble prevention. Bubbles, which they can result from a few different things, but mainly anything that changes the fluid velocity or any change in the channel geometry in the flow path can cause a bubble formation. And bubbles are one of the most commonly occurring and most annoying issues in microfluidics. Creating a bubble is not only bad for measurement, but it also is just really hard to undo once the bubble's been created. What you see in the top right corner is a basic design of a standard pressure sensor for the in vitro diagnostics market. This is actually one of our designs that we did a few years ago. And it's a flow-through design. You can see bottom left corner is where the product goes in. It bends up, goes to the actual sensor mechanism, and then bends back down and goes out the right-hand side. So this is a flow-through design, but those bends in the flow path we found were detrimental. They create dead volume. There's dead volume in every single bend. And additionally, those bends, those changes in channel geometry and in flow path, they can actually create bubbles. So that's bad for the process. Couple reasons why bubbles are bad. They can result, number one, in too little sample reaching a detector. Any type of optical sensor or detection mechanism would not be able to distinguish a bubble from any other type of sample. So, it could cause an error in absorbance detection. It could also just mean that you don't get enough sample to the measurement mechanism as you've got bubbles in there that your system can't detect without a specific bubble sensor. In a worst case scenario, like a point of care application, if you have bubbles in a bloodstream, you can really hurt somebody. So you want to eliminate these wherever you can. And if you remember back to the picture of the flow-through sensor that I had on the previous slide, a true flow-through design prevents bubbles from forming to the extent possible with good process control. You should be able to keep it from there. But if you have those bends in your system, specifically from a pressure sensor like the one I've shown above, you could either hurt somebody or just hurt your system and get bad measurement. Keep in mind, bad measurement's really expensive. A patient doesn't want to hear that, we got a bad measurement, I got to draw some more blood. That's costly, not just in terms of, people's time, but also in terms of the pain it can cause a patient. So we think a flow-through sensor helps you prevent bubbles that leads to both better measurement and better outcomes for the patient. So the last part of accurate measurement, the last couple slides we've been talking about achieving accurate measurement. The last part of that is measurement integrity, and really that comes down to some system basics. A lot of times our customers are working with either biological samples or samples that have ion affinity, that sort of thing. And you have to be careful about your wetted material selection. So just some basics on a flow-through sensor. Our standards, are 316 stainless steel. We also have grade 5 titanium elements. So all the wetted materials should be resistant to any sort of biological inertness or biological material. Recently, we've also created an ion inert element, which is made completely of sapphire. It's actually a three-piece design, and it's completely it's patent pending. It's a three-piece design. The two fittings are peak-lined stainless steel, meant to fit 1/16 inch tubing. They're compatible with either Marvel X or Viper ports, which, as you know, are hand-tight fittings. But that sapphire element in between the two peak line fittings is completely inert. It's made from a single crystal sapphire, and it's the only one on the market. So for applications like ion chromatography, this is the best you could possibly get. The other benefit is that where a lot of sensors that are ion inert only go up to about 6,000 psi. The sapphire has been proven at 10,000 psi operating with a 12,000 psi yield. So that increase in pressure for a chromatography application is quite valuable, and we haven't sacrificed accuracy to get there. In fact, what we see from the sapphire is it actually, because it's single crystal, gives almost better accuracy than what we get out of a metal element. So as you think about preventing sample contamination from the actual wetted materials, we have some options to think about in terms of material selection and what best fits your system, and we can help with that. Okay, so we've talked about achieving repeatable, reliable, accurate measurement. Let's change gears, going back to the beginning value statements that I made, and let's talk about improving operational productivity a little bit. Specifically, when I think about operational productivity, I'm thinking about diagnostic end users, people who are trying to um, increase the number of measurements that they can make on a daily or hourly basis without increasing their lab footprint by installing secondary instrumentation. The catch to this is that a lot of these instruments have either high pressure, low flow, or just extremely low flow rates that work against those throughput needs. So you have this basic technology versus what the market wants that are kind of in conflict. To overcome this conflict, manufacturers essentially have two options. They can increase the amount of carrier fluid. I've heard this called eluent, analyte. There's a bunch of different names depending on what market segment you're in. The problem with this method, using more carrier fluid to push a sample through faster, is it reduces the what I'll call selectivity or accuracy or resolution of the sample. It also increases the cost of that eluent. So once you use that eluent, it's gone. You have to pay for whatever the next sample needs. So to use more of it is costly to the end user. That's not the solution they want. And you're also limited because sample sizes are decreasing. They're getting smaller. The amount you're getting from a patient or just any other sample is smaller. You can't continue to just increase that eluent amount. There's a limit to how far you can push that. So you have to look at some other areas. What I see as a more successful option, which I think is well understood by manufacturers, is to decrease the volume of their system. Now, a traditional, I'm going to turn this again to pressure sensing, but a traditional pressure sensor, typically the lowest I see is 50 to 60 microliters. A lot of that has to do with being a deadhead sensor. It just adds volume to that system. It adds a T-fitting, that sort of thing. So DJ a couple of years ago, in cooperation with a manufacturer we were working with, we came up with a way to just make it smaller through using this flow-through technology and actually not putting the sensor mechanism itself inside the process. So we have three different elements. Our standard element is about 13 microliters, which is already market leading. But we figured out a way to narrow the through hole size from the DF element is about 0.05 inch through hole. We made a low volume version of that, which works equally well, which goes down to 1.6 microliters. So that 1.6 microliters, I haven't found another sensor manufacturer who's even close to that. We really are best in class when it comes to internal volume of our sensors. In addition, I mentioned our Sapphire element. That is a 20 microliter. There's some reasons we had to make that a little bit thicker to meet the pressure requirements. But still, 20 microliters is quite successful. And by helping our customers decrease the volume of their systems, we can help them maintain their pump budget, so you can buy a lower horsepower pump and just decrease the overall package size of your system. So there's a lot of benefits to this, and in the end, it really does help the end user operational productivity. So internal volume is a huge deal in terms of operational productivity, but also I think reducing the amount of lab space is important as well, because the building structures for hospitals and laboratories are pretty fixed. So if we can make equipment smaller as a group effort, we can help do more in that lab space. And to that effect, DJ has tried to reduce the overall external packaging size of our pressure sensors as much as we possibly can. Our smallest version going down to about 0.4 cubic inches. I actually think it's a little less than that, but it's about 6.7 milliliters, which is just tiny. So this helps OEMs reduce their footprint, which in turn translates to better lab space for the end user. The other thing is, having a sensor this small really allows for commonality and cost leverage between instruments by a manufacturer. So, if you're making one instrument today and you buy the smallest thing available, 2 years from now, when you're trying to design something even smaller, chances are my sensor is going to fit, which gives you both cost leverage and just quick manufacturing or quick time to market. So we used this one before. It's tiny, it fits. We don't have to think about how we rework it or create a new sensor that's going to fit our package size. We have the smallest thing that's available. Let's keep using that and go down that road and get to market quickly. The other interesting thing is, let's say your system runs at, I don't know, 1,000 psi, and you want to make something that's 250 psi or 10,000 psi. For our sensors, that difference, it'll change the element, which is the sensing mechanism, but it won't change the overall package size. So we can quickly create a version of that, and at a higher pressure, and you can just use it. Finally, and this is transitioning a little bit, but the last part of operational productivity I want to talk about is service. If a system goes down or has issues, this is a major problem for the end user, because again, they're not PhD levels, they're laboratory technicians. They don't want to think about fixing this themselves. They have to call in a service person. Chances are the instrument manufacturer is selling service packages with their unit anyway. So that's just downtime that a hospital or a laboratory just can't really afford. So as we created this flow-through design, what we're finding is one of the things that people like most about it is that it's only 2 fittings. So if you compare that to a flush mount sensor or to a deadhead sensor, you're installing that in a T fitting, so that's more places for leaks to occur, and especially at high pressure, leaks are a killer. And especially when a service technician goes in and he's doing some work on the system, that's when we find that leaks happen the most. Mistakes happen in the field. That's kind of a part of life. So to have less places where mistakes can occur, to have that one less fitting is actually quite valuable. So our sensors target that by only doing 2 fittings, plugging straight into your tubing, really easy connections that service technicians are used to working with. So with that, that's about all I wanted to talk about in terms of how I think DJ creates value for instrument and diagnostic instrument manufacturers. I do want to end just quickly with a couple things that we've been working on. The first is our new differential DFI. It's a flow-through sensor with a differential output, and it's meant to reduce environmental noise. We've noticed that a lot of manufacturers are worried about the noise inside their measurement system and trying to reduce it to the extent possible. So we've gotten our sensor down to about 300 microvolts peak to peak at full scale, which is quite the engineering effort, as it turns out. But that product is shipping now. And it's our smallest ever package size, so it's 0.32 cubic inches. You can see a picture of it on the right, very, very small. The other thing we did is we actually went up in size, which is a bit contrary to what I've been talking about in this presentation. But we've actually created a 1/4 inch internal diameter flow through to take on some different applications. We had a chromatography manufacturer come to us and say, hey, we know your pressure sensors, but we do our own column packing. Is there any way you can create a larger diameter version that would work for our manufacturing line? So we said, yeah, sure, and we turned it out, and so far it's working very well. But this allows us to go into a couple different areas where you're doing fluid dispensing or some sort of liquid packaging, that sort of thing. And you can mount this flow-through sensor right in line, reduce leak points, all that good stuff, minimize your piping volume. So we think this has a lot of applications. If you're interested in that, please don't hesitate to reach out to us or for anything else, really. And that's about it. I wanted to make this webinar short and impactful. I didn't want to take up a lot of your time. I do appreciate those who stuck around and gave me their time, so I can let you go back to your day jobs. If you have any questions, there's a couple places you can go. You can go to our website, www.djinstruments.com. As I mentioned, there's another webinar that's already on that website, or there's a link to it that we did through IEEE back in December. I urge you to go look at that one, learn a little bit more about our products and just kind of the basics of pressure sensing. In addition, I'm always available. I respond to email very quickly. If you have questions or you want to learn more, please don't hesitate to reach out. And with that, that concludes our presentation. I'll hand this back over so we can begin the question and answer period.
And now let's get to the Q&A. We do have time for some questions. If we don't get to your question, please note that the complete Q&A transcript, including answers we may not have time for, will be posted with the webinar when it goes into on-demand mode. Okay, our first question is, does the zero dead volume sensor prevent microbial growth?
It's a really good question. I would say it helps prevent microbial growth. The idea with the flow-through design is that the internal diameter of the flow path is the same as the tubing you're using. So, you know, in terms of dead volume, there's no place for microbial growth to really stack up. One of the things that we want to do that we're kind of working on now is coming up with the right set of tests to validate that. We think if we can run some dyed fluid through the sensor and then rinse it and then measure what dye is left in a clean water environment, that we could actually publish a white paper, but that's still forthcoming. So that's good question. I know that's really important to some of the IVD applications, just preventing that microbial growth. So I'd say our sensor very much helps that scenario. Obviously, there's a lot you need to do to prevent it completely, but it's a really good starting place.
Can you customize these sensors to fit a specific application?
Yeah, so I think I mentioned this a little bit, but you know, DJ Instruments is an original design manufacturer, so most of what we do is customized in some way. That could be mechanical fittings, electrical connections. You know, if you have specific requirements for electrical output or noise or you know, any custom spec that you want to meet for your system, we can work with you to make sure we achieve it. So yeah, these are very customizable.
Okay, next question. What communication protocols do your sensors use?
Right, good question. So 90+% of our sensors right now are using just a voltage output. It's usually 0.5 volt to 4.5 volts output. We know that customers are using more digital communications, things like SPI and I2C, and that's what we're looking for. We are working on a solution to that to develop a microcontroller-based product that could drive that. One of the big advantages of moving to that kind of communication style is it limits the number of cable connections at the customer level. So if you have 8 different sensors in your system, like pressure sensors, and they all run on the same I2C or SPI communication, you can daisy chain them together and only have one connection point to your control board. So customers really like that, and they're looking for that as well.
Next question. What is the accuracy of one of these pressure sensors?
The standard accuracy is 0.15% of full scale, and that's a combined accuracy statement that includes nonlinearity and hysteresis.
Next question. Do your sensors hang off the process tubing?
All of our sensors have places that you can mount a bracket to, so they're pretty easy to connect. I think with 1/16 inch tubing, I wouldn't recommend not using that and having them free floating, just because it could pull the tube down and do something weird. Yeah, so we have screw connections that you can mount a bracket to.
Well, that's all of our questions, so we're going to wrap up this webinar now. Thank you to our presenter, Eric James, and thank you to all of our audience members for being a part of this webinar event. Take care, and we'll talk with you soon.